But strange things start happening with complex numbers for an integer k.
Now that everyone knows that each of the 2k pi I equals 1, say we make k different things.
Now say we do everything to the 1/2 power.
So that's here and here.
What about the 1/3 power?
And if you plot the points,
And every time you add 1 to the root's power, you get 1 more point. I wonder if the infinite root of 1 would be every point on the unit circle. Well, in order to find the points of another equation, say I to the 1/5, I am the same as 1e to the I pi halves. First, since it's a fifth root, we make a pentagon. Next, we expand it by 1. Lol. Then we turn it pi halves times 1/5. And that's all there is to that. And you can also shade things like negative 0.5z cubed, where 0 is less than or equal to arg of z is less than or equal to 3 pi over 2. And then there's taking derivatives. If you graph f of z, there are 2 inputs and 2 outputs, so you end up in 4D.
I'm the mean value theorem.
There's no mean value theorem here. I have destroyed it, and now it is dead and complex.
Well, that's just, why?
Well, imagine a spring. Since it's 3D instead of 2D, there's not a point between the beginning and end of the spring where the slope is straight up, like if you were to connect the ends. The same is true in 4D, which is what we were working with.
Well, you could have just told mean value theorem to go away instead of, I don't know, like smushing
No,
it.
he had to die. Anyway, as I was saying, with a derivative, you can come from either the negative or the positive, but with complex numbers that we are graphing in 4D, you can come at a lot more angles. So finding it doesn't always work because you'll get 2 different answers depending on where you are coming at it from, which then will say it's not differentiable. For example, if f of z equals rez, first we let z equal to x plus yi, and then we stick it in the definition of a derivative. Then we trade the f of z for the rez. So if we come at delta z approaching 0 with delta x approaching 0, we get 0. But if we come at delta z approaching 0 with delta y approaching 0, we get 1. So this problem is not differentiable because we can get 2 different answers.